It's Danny Fish, it's Sunday, and it's science. And we are going to discuss salt. Salt is kind of weird, very mysterious. Its flavor, ice melt on the sidewalk. Something happens when you add it to boiling water, slows the fermentation down in yeast, jack of all trades. Let's start with the simple thing, which is adding salt to food to add flavor. Salt is a compound, sodium chloride. And that compound is going to react to the different compounds in different foods differently. It essentially reduces bitter flavors and enhances sweetness, which is why you will always find at least a teaspoon of salt in any baking recipe. That's the easy stuff. Let's talk about salt in water, more specifically boiling water. To help you better understand salt with boiling water and salt with ice in general, let's just talk about water first. Water comes in three forms, obviously. Solid, liquid, gas. Solid being ice, liquid being liquid water, and then gas being water vapor. Now that we got the basic, let me help you further by giving you this little visual. Say you are by yourself, one single water molecule, and it makes it very easy for you just to vaporize on your own. Now, for you to be free-flowing water, you need to be holding hands with two other water molecules. So like your friends. You're not like really on top of each other, but you're holding hands, you're liquid, you're flowing, you're doing your thing. Water. So if you were ice, you and your friends that you were holding hands with would actually all come together, and now you're just hugging each other really tight. Really big, uncomfortable group hug, which would totally not be allowed right now. Now that you have that visual, hold that in your head, keep that in mind. So you put a pot of water on the stove to heat it for some pasta. We're Italian, and most of the time that's what we're doing. What happens when you start to heat the water is the heat and the energy from that heat goes into your water molecules, and they start moving around a lot. Now remember, if you're a water molecule, that means you're holding hands with your other friends here to be water and to not be vapor, which is you by yourself. But because you're moving around and there's all this heat making you jump about and such, if you keep moving around too much, your friends are gonna let go of your hands and you're gonna become water vapor, which is what happens when water boils. This process of water boiling happens at 212 degrees Fahrenheit. As your water starts to evaporate, it gets cooled, it becomes back to water droplets, and it kind of cools down your water again, keeping it somewhere at a consistent 212. But what about the salt? Most people think that when you add salt to the water, it helps the water boil faster. You're wrong. When you add salt to water, think of it as making the water like heavier. Picture you and your friends holding hands, and now all of you are wearing really heavy winter coats. As the water heats, or as you and your friends heat up, you're not going to be able to bop around as much as you would if you weren't wearing a heavy coat. That means that your water can absorb more heat before it separates from its friends and evaporates into boiling water. That means your water can get hotter before it boils. So now that 212 degree threshold that water has, and then it boils, now gets jacked up almost 30 degrees when you add salt. This means that you can cook your food at a hotter temperature, can make the cooking time shorter, or whatever it is that you're aiming for, plus adding the flavor of the salt, which is very important. But wait, what about salt and ice? We all know that when it snows or it's about to snow, they put salt down to break up the ice and to make all the roads safe. But why? Remember, when you're ice, you and your friends are hugging each other really, really tight. And then all of a sudden, someone comes along and gives everybody the same winter coats that boiling water got. We're gonna start to spread out. It is getting toasty. Point isn't that salt makes ice warm. What it does is it actually makes water be able to tolerate colder temperatures. It's literally the same exact effect as if you walked outside in 32 degree weather without a coat on. You would freeze. You put this big coat on, and now you can walk outside in 20 degree weather and not freeze. That's what salt does. It lowers the freezing point of water. Instead of water molecules becoming an ice cube at 32 degrees Fahrenheit, It might not become an ice cube until 20 degrees Fahrenheit or 2 degrees Fahrenheit, depending on how much salt is in the equation. Ultimately means it will stay liquid and colder longer before freezing. Same way it made the water hotter for longer before boiling. I don't know if any of this made sense or if I got like lost in the hugging analogies. I really don't know. What have we learned today? For one, you need to add salt to your food. Sweet, savory, whatever it is, it helps out. What it is doing is raising the boiling point so your water can get hotter than 212 degrees and then boil, so your food could cook faster. And lastly, number 3. Salt prevents ice and melts ice by lowering water's freezing point temperature, so it can handle colder temperatures without turning into ice. All hail sodium chloride. If you like these science videos, please let me know. Somebody out there, are you even watching? Is it just my mom? I have 3 brothers, so that's like 3 views right there. If there is a science question you would love to know the answer to or would just love to see me ramble about, feel free to shoot me a DM, an email, a comment, whatever you got. If you have my cell phone number, call me anytime. I'm pretty bored. If you haven't already, please make sure you subscribe to my YouTube channel, you follow me on Instagram, you tell everybody you know about me. Thumbs up, like it, comment, lick it, love it, tap it, boop it, bop it, whatever you got. I'm here for it. I'll see you later this week for a new recipe, and then I'll see you next Sunday for some more science. Goodbye.